Hi there, this is Miss Barber. The title of this lesson is Savings Plans and Investments. The learning objectives for this lesson are: understand concepts and vocabulary of loan savings plans and investments, calculate and interpret balances using the savings plan, which is called the ordinary annuity formula, calculate total and annual returns, use investment tables, calculate bond yields or bond interest, and solve applications involving savings plans and investments. Savings plan or ordinary annuity. How much would be in an account if $200 is deposited at the end of every quarter into an account that pays 12% compounded quarterly for 2 years? Solution. To find the total amount, we can calculate the account balance at the end of each quarter and then add the ending balances. The table shows balance at the end of each quarter. The table has 4 columns and 9 rows. The first row labels each column. The first row, first column is the quarter. Numbers following it are 1, 2, 3, 4, 5, 6, 7, and 8 for each of the quarters. The next column is titled Amount Deposited at the end of each quarter, and that's $200 for every entry. Next is the formula for amount at the end of the 8th quarter, and each of these we use a compounded interest formula, and what we change is the number of quarters. That's the exponent. And finally, the last column is labeled Amount Deposit has grown to by the end of the 8th quarter. So now let's look a little bit more closely at the second row, which addresses the first quarter. In an ordinary annuity, the $200 is deposited at the end of the first quarter, and so if we look at the formula, we have A equals 200 times the quantity, 1 plus 0.12 for the APR, divided by 4 for the number of compoundings, but in the exponent you see 7. Remember, we are counting quarters, and if we have 8 quarters in which for the money to earn interest, after the end of the first quarter, there is only 7 quarters remaining. With 7 quarters remaining, the $200 interest increases to $245.97. Let's skip down to the row that addresses quarter number 5. The deposit is still $200. All of the compound interest formula is the same except the exponent. On the exponent, the number is 3, and that is because after money is deposited at the end of the 5th quarter, there's only 3 quarters remaining to earn interest. So the $200 deposited at the end of the 5th quarter will have increased to $218.55. Let's observe, that's a bit less than the amount earned for the first quarter investment. And on the last row, it's kind of silly. It's quarter 8. Deposit $200. Since there is no time for interest to accumulate, at the end of the time that you deposit it, which is exactly the same time, you still have $200. Now, to determine how much you have at the end of this time period, add each of the entries of the 4th column. When those 8 entries are added together, we get that the total balance is $1,778.46, which is $178.46 more than the $1,600 that was deposited. Savings plan formula. This is actually the ordinary annuity formula. We use the ordinary annuity formula when we make regular periodic payments. The formula is A equals PMT times the quantity 1 plus APR over N raised to the power of the product of N times Y minus 1, all divided by the quantity APR over N. A is equal to the accumulated savings plan balance. PMT is equal to the regular payment or deposit amount. APR is equal to the annual percentage rate expressed as a decimal. N is the number of pay periods per year. Y is the number of years. An annuity is a series of equal periodic payments. This savings plan is called an ordinary annuity because the payments are made at the end of the payment period. This formula will be provided for you on all future tests. So, example, what will you have for your retirement? You decide at the age of 25 to start an IRA. IRA stands for Individual Retirement Account to plan for retirement. You make deposits of $75 at the end of each month, and the estimated average APR is 8.5%. How much will you have when you retire at 65, which is 40 years later? So for the solution, the first step is always to identify the formula. Write it down. The formula is the ordinary annuity solving for the account balance, and it is A equals PMT times the quantity of the quantity 1 plus APR over N raised to the product of N times Y minus 1, all divided by the quantity APR over N. Identify the formula. Write it, ordinary annuity formula. Second is identify the components that's given to you in the statement of the problem. A is the future value or account balance. The last sentence of the question is how much will you have? And so the future value is followed by question marks because this is the value for which we are solving. PMT is the payment that is made regularly. In this problem, it is you make deposits of, and so your payment is $75. APR, which is the annual percentage rate, is 8.5%. To express in decimal form, we would write that as 0.085. Remember, to change a percentage to a decimal form, you move the decimal point to the left 2 spaces. N is the number of compoundings per year. Since it's each month, it'll be 12. And Y is the number of years. And in the statement of the problem, it is 40. So you identify the formula, identify the parts. Next, compose it, put it all together. So we're going to replace all the letters in the formulas with the numbers. We would write A equals 75 is going in the place of payment, times, and then bracket, and then open parenthesis, 1 plus 0.085, which is your APR, divided by 12, which is N, raised to the power of N, which is 12, times Y, which is 40, and all of that minus 1, close bracket, divide that by the quantity 0.085 divided by 12. This can get overwhelming very fast. Take your time. Do each of the steps. Now to compute work from the inside out, I recommend you take steps. So we'll do 75 times, and in the brackets of the parentheses, I have 1 plus. In your calculator, key in 0.085 divided by 12, and that should give you 0.0070833. Do not round during computation. And that raised to the product of 12 times 40, that's 480 monthly payments, still minus 1. And all of that is divided by the APR divided by 12. In your calculator, 0.085 divided by 12 is 0.0070833. Let's continue. So A equals 75 times, and in the numerator, in the bracket, and now in the parentheses, add 1 and the decimal. So that's 1.00708333 raised to the power of 480, and that quantity minus 1, and the denominator goes unchanged, so it's still 0.00708333. Let's continue to simplify. A equals 75 times. In your calculator, key in 1.00708333, raise that, that's what looks like an upside down V on your calculator, to the power of 480, and write the full expanse of the digits you see on the calculator. Should be something pretty close to 29.60712069, still minus 1, that's in brackets, divided by the denominator remains unchanged. Continuing, A equals 75 times, and in the numerator we now subtract the 1 from the expanded decimal, so we'll have 28.60712069, still divided by the 0.00708333. Don't skip steps. So we'll go to A equals 75 times, compute the quotient of the previous 28.60712069 by 0.00708333, and that quotient will be 4038.652523. Now multiply that with the payment of $75. The account will have $302,899 at the end of 40 years. Now let's look at what is amazing. The total deposits was just $36,000. $75 a month, so 75 times 12 times 40. That is, you have earned $266,899 of interest. Ain't that cool? Summary of definitions. An annuity is any series of equal regular payments. An ordinary annuity is a savings plan in which payments are made at the end of each payment period. An annuity due is a plan in which payments are made at the beginning of each period. The future value of an annuity is the accumulated amount at some future date. The present value of a savings plan or an annuity is a lump sum deposit that will give the same end result as a regular payment into a plan.